in this project. So we have been considering about the different biology subject from these two universities, and also the law subject from Auckland University, and several medical subjects data from UK University. And we also present this. We will present this I learned LLM framework, which is kind of the iterative self improvement framework. So you can see there's a multiple choice question explanation generation module, and there's a explanation evaluation module. So these two modules will interact each other, and so the generated explanation will be evaluated by the explanation evaluator mode, and then the evaluation score will be sent back to the explanation generation module, and then to kind of doing the multi-step, multi-term enhancement, and eventually we will generate a high quality explanation given by the, for example, the top K iteration. And here are some experiment results. We can see we have been explored using, for example, the llama-based 13 billion model. So we can see in some of the experiment results, so we can see find out the best performance can at the, for example, at between the step 2 and step 3, and also our method can also be help this GPT series model, which without any fine tuning. So it's kind of doing iterative instruction prompting, and but the improvement is not greater than the kind of the open source model, since we can doing the instruction fine tuning. And so in general, we can see the basically the I-learner framework using this iterative generation, explanation generation, and the assessment for learners using multiple choice question explanation. And yeah, we explored Llama 2 and 13 billion and the GPT-4 to achieve better blue score and bird score. And we actually have done our future work, so I will present this future work in the later slides. So trying to using, for example, integrate the logic reasoning and also the reinforcement learning to generate the explanation not only look like student written, but also it's logically coherent and logically consistent. So here's some paper link and project code. So, and also this is second paper we have been published at the ACL 2024. So this is basically using abstract mini representation to do the logic-driven data augmentation for logic reasoning. So basically, the background is the pre-trained language model are actually to achieve good reasoning. It's a very important step towards strong artificial intelligence. But in the real world, we can see there are not too many robust and high-quality reasoning data set. So in this case, we try to automatically synthetic this high-quality reasoning data set to doing the kind of the continue pre-training, and then to benefit the downstream reasoning task. So the basic idea is we can see the tool that we have been using is called the abstract mini representation, which is kind of the mini representation. You can see the first two sentences. They look different. Sorry, but basically the meaning can be represented using the same mini representation. And also, you can see there are some nodes. For example, the condition nodes can be extract and represent by using the, for example, the if can be identified as the condition node, and the not can be identified to the negative polarity node. Sorry. So based on this kind of the mini representation, we can kind of represent this natural language reasoning task to the kind of logic program based representation. So in this case, we can extract the real the real meaning representation instead of the kind of the syntax based representation to really improve the generalization performance for our method. And we consider different logic equivalent law, for example, contraposition law, implication law, commutative law, and the double negation law. And here are some of the basic pipelines. So input is a natural language sentence. We can represent to a AMR graph, and then to do the different logic equivalent law to modify the AMR graph to generate a logic equivalent AMR graph, and then we can kind of convert back to a natural language sentence, which is kind of original, equivalent to original sentence. Yeah, this is a pattern, and then we can do a logic equivalent identification constructive learning to do the stage 1 training. To do kind of the general and to improve the foundation model reasoning, and then to we can do downstream task to directly train some specific reasoning task. And we can also using our method to help this generative large language model, which does not need any training. So you can see in the original part, there's no directly solution pass from the context option. But in our method, we can generate the extended option. So we can basically generate 2 solution paths to find out option B is correct. And here's some experimental result. We can see from the right top corner, our method is the number 1 on this leaderboard, and also there are some other methods from different company and university around the world, such as Alibaba, Microsoft Research, and also kind of Singapore National University. Yeah, and here's some useful link, the model weight for the project. And we also have done some, this is the extension work and feature work for the previous projects. For example, the I learned project, basically we are extended to the reinforcement learning to reward better explanation, and also so generate the explanation not only similar to student written, but also can be logically consistent from the given context and answer and the correct option. So, and also for the next extended project is we actually so we have done a multi-step reasoning data set for the deeper reasoning depths to AMR LDA, which is the project we have been present, and also we have done some robust reasoning, which is trying to consider more logic reasoning and also try to do more change for the multi-step reasoning task. For example, we can remove some critical rule from the context, and then to test model if the model can, whether the model can answer the question correctly. So in most cases, if there's no this critical rule, the model still can answer this question, then that means the model is trying to using the pre-trained knowledge to answer the question instead of using the given rule and given facts to answer the question. So this is kind of the hallucination we can evaluate model. Yeah, and also, yeah, here's some detailed explanation for the unlearner LLM, which is, basically it's using the train a large language model using these ILP words to written explanation and the iterative learn better. So, and also this paper is kind of the extension, and then it's redefine the quality of the explanation, including not only the blue score and bird score, but also the we evaluate using another model, natural language inference model, to evaluate by given the generated explanation. Can we use the generated explanation context and question to logically infer to the answer, whether the answer is correct or not. So this is kind of adding this logic consistency into this training process. And here's the multi-step reasoning task, which basically is multi-step. Basically, is given each step is a rule, so given multiple rule, and can we infer the given the question, whether the question can be inferred from the given context. Yeah, so and also we present this IMA glove gate attention model, which can even demonstrate better. So it's not a pre-trained model. It's actually training from scratch, can still perform better than the pre-trained model especially on out of distribution generalization scenario. And the gate attention that we have been using in this paper has been also referenced by the Alibaba group for the latest Qiming model. They also reference the idea of gated attention mechanism. And here's the extension paper that we have been done that kind of consider if we remove some critical rule from the context and inject some contradictory evidence, and kind of rewrites the logic perseveringly, and and also we can integrate the logic equivalent to rewrite the group, so can model still answer correctly. And also we demonstrate our reinforcement learning process to given each reasoning step to basically to verify by given the answer that we already being inferred, can we using this infer to infer and verify the next step reasoning. So it's kind of the step-by-step verify reasoning solution. Yeah, so here are some published paper that we have been introduced in the previous slides. Yeah, thank you for your listening. So if you have any questions, so yeah, feel free to ask me or send me an email as well. Yeah, thank you.
Thank you so much, Dr. Bilbao, for this absolutely brilliant and outstanding session. Your insights on how AI can transform our research and workflow were truly eye-opening. We are incredibly grateful to you for joining us all the way from New Zealand and sharing your world-class expertise with our global community today. Thank you so much, sir, once again.